Okay, you are good to go. You have done what is called financial management. Now, this one is advanced financial management, which means the concept will remain the same. The concept will remain the same. That's why we have the capital budgeting in the financial management. Also, in the advanced level, we have the capital budgeting, Maybe just a quick reminder on what we learn on the financial management about the capital budgeting, where we said for the capital budgeting, we have environment where the investors operate under the capital budgeting. We have the environment with what? With certainties. The environment with certainty. And number two, environment with uncertainty. Uncertainty. So when we say certainty, is that we are certain of the outcome. We know what will happen. And for uncertainty, we don't know what will happen. So in this financial management, you need to remind yourself that. And we say it for an environment of certainty, this one, you know in advance what will happen. And therefore, the probabilities are provided. Provided in this case. But for this one, you don't have the probabilities. Because we are uncertain, we don't know what will happen. And in the financial management also, you are taught how to measure the risk. Who can remind us the method of measuring the risk? Who can remind us the method of measuring the risk? We said the risk are being measured by, so maybe you can say tools used to handle the risk. tool used to handle the risk. And we have what is called expected monetary value. Expected monetary value. And then number 2 is the standard deviation. The standard deviation. And number 3 is the CV. That is a coefficient of variation. Coefficient of variation. So this method of standard deviation we used to measure absolute risk. We used to measure absolute risk. That one we use to measure absolute risk. And for the coefficient of variation, this one we used to measure relative risk. We used to measure the relative risk. This is what you did under the risk and assessment in the financial management. So let's have a quick illustration on how to calculate the standard deviation and also how to calculate the expected monetary value, and also the coefficient of variation. So let's have an illustration. Let's have a small illustration so that we can remind ourselves how to calculate the standard deviation, the coefficient of variation, and also expected monetary value. So write the illustration. We have the nature. The nature here is A, B, C. And then let's give the probabilities. Let's give the props, which is 0.2, 0.2, 0.3, and 0.5. Let's give the return of X and also the return of Y. The return of X and also the return of Y. Remember, when we talk of the returns, we are talking in terms of the percentage. So always the returns are in percentage form. So we have 10, 15, and 16. This one 20, 25, and 30. And then required number 1, EMF, the expected monetary value, and number 2, the standard deviation, and the CV. Required number 1, EMF, number 2, the standard deviation, and number 3, the CV, and number 3, the CV. So when we talk of the expected monetary value, here we're simply talking of the returns of, or what, the expected return. We're simply talking about the expected return. We are simply talking about expected return. And how do we compute the expected return? How do we calculate the expected return? Very simple. You do what? You take the probabilities attached times the return. You take the probabilities times the return. In this illustration, we have been given the return and also the probabilities. So we can comfortably calculate the expected return of X and Y. So we come here, write the solution. It's just a quick reminder of what you did under the financial management. So solution, expected return of X and expected return of Y. Expected return of X and the expected return of Y, and expected return of Y. So I will take the first probability times the first return. So for this one, I will come here, say 0.2 times 10 plus 0.3 times 15 plus 0.5 times 16. That one will give me the first expected return of X. The first expected return of X. The same case with return Y. I will come take the same probability times the return, which which is 20, plus 0.3 times the return, which is 25, plus 30 times 0.5, 0.5 times 30. I'll be able to get the expected return of y. So let's have the calculator. We do the calculation. So for the first one, kindly confirm if I'm getting the correct one. This one I'm getting 14.5. Kindly confirm with your answers. 14.5. The second one is 26.5. The second one is 26.5. The second one is 26.5. So now we have answered the first question, which is expected monetary value or the expected return, which we say simply you take the probabilities times the return. So this is the solution. This is the solution. And then, so we can have to write that one so that, because we will need to use it. So we have 14.5 and 26.5. So the second question is asking for the standard deviation. The second question is asking for the standard deviation. Who can remind us? We say the standard deviation used to measure which types of risk. Standard deviation, we said, it is used to measure the absolute risk. It is used to measure the absolute risk. And when we say something is absolute, it's simply 100%. It's simply 100%. So the standard deviation is used to measure absolute risk. So you need to know the definition and the use. And then how do we compute the standard deviation? You have done quantitative analysis. How do we compute the standard deviation? So standard deviation, my good student, is just the root of what? The root of variance. Is the root of variance. So now the question is, how do we calculate the variance? So to calculate the variance, you take the return, maybe example, the return of x minus the expected return of that x. Whatever we are getting here, you do what? Do the square and multiply by the probabilities. You do the square and multiply by the probabilities. That's how we calculate the variance. So let's have the variance now of our nature ABC. So we can have it here. So I hope that one you can able to see. So I will come here, say A, B, C. So we do for project, this is for return X, So I will take the expected return, which we got here 14.5, but the return is 10. So I will take 10 minus 14.5. I squared, I multiply by the first probability, which is 0.2. The second one is the return of 15 minus the same expected return. I squared, I multiply by the probability, 0.3. I'll get my answer there. Another one is 16 minus 14.5 squared multiplied by the probability, which is 0.5. So whatever you will get there is what we refer as variance, And that for project, for the return y, we will do the same. For return y, I will come here. This is for y. A, B, C. The expected return, the return is 20 minus the expected return, which is 26.5. Multiply squared, multiply by the same probabilities. Multiply by the same probabilities, and then the second one is 25 minus 26.5 squared multiplied by 0.3. And the last one is 30 minus 26.5 squared multiplied by 0.5. So let's have the answers. Let's have the answers for that. That is, you can, someone can do for me this. Someone can do for me this. If you have a calculator, let me do for X. Also, don't forget to get the sum. After getting all of them, you do the summation. Now we have the variance. Now we have the variance. So for return Y, we have 15.25, and for return X, we have 5.25. So having the variance, now get the standard deviation. So the standard deviation of this, I will get the root of 5.225. This one, I will get the root of 15.25. So let's see the first standard deviation. So root of 5.25, which is 2. This one is 2.929. What about 15? Root over 15.25, which will give us 3.91. So we have the standard deviation. So which means if you compare these two projects, this one has high risk compared to return X because of what? The standard deviation. This one is more compared to that one. So that's how to calculate the standard deviation. First, you calculate the variance. After calculating the variance, do the root of that variant, the square root of the root of that variant. Now we have done with the second requirement. The third requirement is the CV, the coefficient of variation. That requirement is the CV, the coefficient of variation, Because without this knowledge, you cannot do the advanced capital budgeting. You have to remind yourself what you did in the intermediate level. So CV, the coefficient of variation. How do we calculate the coefficient of variation? You take the standard deviation, you divide by the mean, and then you multiply by 100%. So this one, we take the standard deviation, we divide by the mean, and then we multiply by 100%. So for X, we have the standard deviation ilikuwa ngapi? 2.29. We divide by the mean. The mean, how do you get the mean? How do you get the mean? Take the sum of the return, which is 10 plus 15 plus 16, divide by the number of the returned, which is 3. That one will give you the mean. So let's take 10 plus 15 plus 16 is giving us 41. 41 we divide by 3. 41 we divide by 3 inatupia 13. We are getting the 10.67. So here divide by 13.67. So what could be the CV? So I take my answer 2.29. I divide by my answer. I'm getting times 100. I'm getting 16.76%. So that is the CV. That is the CV. That is the CV. And then what about for Y? So the same case with Y, you will take the standard deviation, which is 3.9. You divide by the mean 20 plus 25 plus 30. You divide by 3. Whatever you are getting here, multiply by 100%. Multiply by 100%. So let's get the mean. 20 plus 25 plus 30. We divide by 3. And then 3.39 we divide by answer, we multiply by 100%. So we are getting of 13.56. 13.56. So that's how to calculate the expected monetary value, the standard deviation, and also the coefficient of variation. So that's what you did under the intermediate level. And it is very important because we apply the same concept in the advanced financial management. That is the capital budgeting. So we can introduce now that topic unless there is a question. If there is a question, you raise your concern, or also you can talk through the chat. We are free here. That's why we are learning. So nobody is limited to anything. So if you're not getting, you say, I'm too fast, I'm too slow, so that we can know the rate or the speed we can use. So let's have a subtopic there, advanced techniques of handling the risk. Advanced technique of handling the risk. And specifically, we are looking of environment under uncertainty. Environment under uncertainty, and the environment under uncertainty. We said uncertainty is that we don't know what will happen. We are not certain of the future. We don't know certain of the future. So we have the method. The first method which we use to handle the risk under uncertainty is called simulation. So the first method is simulation. Simulation. And what is a simulation? So to simulate is simply to imitate the reality or to copy the reality. So simply this one is just to imitate the reality, or to copy the reality. So when it comes to simulation, the examiner will give you the state of nature. They will also give you the cash flows. They will also give you the probabilities. So the first step you will do is that you need to get the random range numbers. They will also give you the random numbers, which you have to calculate the random range numbers. So we need to know how to get a random random range numbers. Random range numbers. So we need to know how to get the random range numbers. So in these random range numbers, the examiner will give you the probabilities. The examiner will give you the probabilities with 1-digit decimal and also for the 2-digit decimal. So for example, they will give you a probability with 0.1. They will give you another probability of 0.02. So this one is 1 decimal place and this one is 2 decimal place. So they are different. These are not the same. This one is 1 decimal and this one is 2 decimal. So even when getting the random range numbers, you have to check the number of decimal of the probabilities. The number of decimal of the probabilities. So for example, for us to get the range for this one is 1 decimal. So 1 decimal, you need to have 1 digit. You need to have 1 digit. 2 decimal, you need to have 2 digits. You need to have 2 digits. After getting, for example, you have the major here maybe, or yes, we have the cash flows. The cash flow 10, 20, and then we have the probabilities 0.2 and 0.8 and 0.8. So how will you calculate the random range numbers of these probabilities? How will you calculate the random range of these probabilities? Check the decimal and know which digit are you going to use. So for this, first you need to get the cumulative probabilities. You have to get the cumulative. So I will come here, get the cumulative probabilities, which the first one is 0.2, which will be the same here, 0.2. The second one is 0.2 plus 0.8, which will come to 1.0. So from there, you can get the range numbers. So we said for 1 decimal, we give 1 digit. So it will be from 0. That one digit, you subtract from this last one. So this one is this one is 2. So I will take 1 minus 2. I will take 1 minus 2. So the first one I will have 0 to 1 and then 2 to, and then from here, this one is 10. So this one is 10. I subtract 1, which I will get 9. So it will come to 2 to 9. So that is the first random range. If you have been given 2 decimal place, for example, you have 0.20 and then 0.5 and then 0.0. It should be 1. This one is 7, 0.3. For example, the examiner has given you these probabilities. How will you get the random range numbers? So for us to get the random range numbers, we are first to get the cumulative probability. So this one will be 0.20. This one will be 0.70. I have had this one. This plus this, which is coming to 7. And then this one plus this, which is coming to 1.00. Now get the range. These are 2 decimal place. So which means we are going to use 2 digits. So I will take 20 minus 1. This one minus 1, also this one minus 1. So the first range number, so let's have the range here. So the first range, it will be 0 to 19, because this one is 20 minus 1, it's coming to 19. And then we start from that 22, subtract 1 to 49. And then we start from 52. This one is 100. So subtract 1 will come to 99. So that is the random range. You can see the difference between this and this one. So you have to know the different. So I hope up to that point we are together. If you are not together, then you ask the question before we look at the illustration. So where there is a lot of challenge is how to get the random range numbers, but it is very easy. So long as you have identified, am I going to use the 2-digit or 1-digit or 1-digit? So you can write the illustration. You can write the illustration, and then to say, write the illustration to say, XYZ Limited, XYZ Limited intend to replace existing machine. XYZ Limited intend to replace existing machine with a new machine, which is expected to increase its probability, not probability, its profitability, to increase its profitability over the next 3 years. Over the next 3 years. And then another point you say, due to uncertainty in expected cash flow of this machine, due to uncertainty in the expected cash flow of this machine, the following estimate with the associated probability has been provided. The following estimate with the associated probabilities have been provided. So I hope you have written the full question. So we can have the the years. So we have been told this project goes for the next 3 years. It goes for the next 3 years. So we will have year 1 to 3. So we'll have years 1, and then cash flows, expected cash flow for year 1. For year 1, this cash flow in form of millions. So we have 10, 10, 12, 20, and also 20, 25. That is for year 1. The probabilities, we have 0.3, 0.4, and then 0.2. Remember, we have zeros and 0.10. So make sure this is 1, this is 3, 7 plus that is 1. And then for year 2, the cash flow we have 10, 15, 6, 10, 15, 16, 7. No, this one is 6. And then the associated probabilities also, we have 0.3, 0.30. Make sure to add the 0 because it is very important. And then another one also. And the last one is 0.5 is this. This one is 7. This one is more. It should add up to 0. So we can change this one. This one is 5. So this one also will be 0.03. And then for year 3, we also need the cash flows and the probabilities. So for the cash flow for year 3, we have 10, 8, and 10. The probabilities, we have 0.3, 0.5, and 0.02. Required, number 1, required. So kindly write that one first before we have the required. This one is 0.030, 0.50, and 0.02. Before even you write the required, we have some small information here. You say the cost of capital is 12%. The cost of capital is 12%, and the initial outlay of the machine shall be 27 million. I've said the cost of capital is 12%, and the initial outlay of the machine shall be 27 million. Required A, using expected monetary value. Calculate the expected net present value. Of investing in the machine, of the investment of this machine. So the key word there is just calculate the expected net present value. So Roman 1 is asking for expected net present value. Number two is saying, or B, analyze the risk in the situation above by simulating a net present value, by simulating NBV, and hence calculate the resultant net present value, the resultant net present value. So if you keenly see this one, this one is the concept of what? Financial management. You did financial management, the capital budgeting. Now, in the financial management, there was no expected net present value, but there was net present value. And if we go back a bit to that financial management, we said how to get the net present value is simply you get what? Get the cash flows, you multiply by the discounting factor. Discounting factor. Whatever you are getting, subtract the initial outlay. Subtract the initial outlay. This is the formula on how to get the net present value. But now in advanced level, we are introducing the probabilities. Which means first you need to change the cash flow. So we will not use the normal cash flow, but instead the expected cash flow. We are going to use expected cash flow. We multiply by the discounting factor, and then we subtract the initial outlay. Very simple. So financial management is an easy topic. If you open your mind and take these things, very easy. So don't follow the crowd. You heard of people say financial management is very difficult. No, it's not very difficult. It is a direct unit. We don't need the format. It's just the formula and you move. So let's get first the expected cash flow. So let's calculate the expected cash flows. For year 1, year 2, year 3. So for year 1, year 2, and also year 3, I will take this time is